The story of Roman engineering is, in many ways, the story of the Roman Empire itself, a tale of ambition, ingenuity, and a relentless drive to conquer not just lands, but the very elements themselves. From humble beginnings, the Romans rose to become masters of the Mediterranean and beyond, and in their wake, they left behind a legacy of engineering marvels that continue to inspire awe more than 2,000 years later. The foundation of Roman engineering prowess lay in their ability to learn, adapt, and improve upon the techniques of those they encountered. Early Rome was heavily influenced by the Etruscans and Greeks, both of whom had their own traditions of architecture and construction. However, it was the Romans' practical spirit and organizational genius that transformed these borrowed ideas into true innovations. One of the most significant breakthroughs in Roman engineering was the development and widespread use of concrete. Unlike the weak mortars and mud bricks of earlier civilizations, Roman concrete, or opus caementitium, was a robust and versatile material. It was made by mixing lime mortar with volcanic ash, called pozzolana, and fragments of stone or brick. This mixture could set underwater, enabling the construction of harbors, bridges, and aqueducts unlike anything the world had seen before. With concrete, Roman architects and engineers were no longer bound by the limitations of traditional cut stone. They could mold their structures into vast, sweeping forms, creating domes, vaults, and arches that defied gravity and redefined what was possible. The use of the arch, in particular, became a hallmark of Roman construction. By distributing weight evenly, arches allowed for the creation of larger and more stable openings in walls, supporting bridges, aqueducts, and even massive amphitheaters. Perhaps the most iconic example of Roman innovation is the aqueduct. As Rome's population swelled, the need for fresh water became ever more pressing. The Romans responded by constructing a vast network of aqueducts, some stretching for miles across the countryside. These marvels of engineering brought clean water from distant springs and rivers into the heart of the city, supplying public baths, fountains, and private homes. The Aqua Appia, the first Roman aqueduct, was completed in 312 BCE, and it was soon followed by many others, each more ambitious than the last. The scale and precision of these aqueducts are breathtaking. Engineers maintained a gentle, consistent gradient, often less than 1 meter per kilometer, to ensure the smooth flow of water. Where valleys or obstacles intervened, they built towering arcades of stone arches, some still standing today. To cross low points, they dug tunnels through hills, employing skilled surveyors and laborers. The Pont du Gard in southern France, with its elegant tiers of arches, stands as a testament to the artistry and rigor of Roman engineering. But water was only one element the Romans sought to master. Their roads, too, are legendary. Roman roads formed the arteries of the empire, enabling the rapid movement of armies, officials, and traders. The phrase, "all roads lead to Rome," is more than a poetic metaphor. It reflects the reality of a network that, at its height, spanned over 250,000 miles. Roman roads were built to last, with multiple layers of stone and gravel laid atop a carefully prepared foundation. Their straightness, a result of meticulous surveying, allowed for efficient travel over vast distances. The Appian Way, or Via Appia, was among the earliest and most important of these roads. Built in 312 BCE, it connected Rome to the southern port city of Brundisium, opening the Italian peninsula to trade and conquest. The construction process was rigorous. Workers dug a trench, filled it with stones for drainage, then added layers of gravel, sand, and finally large paving stones fitted together like pieces of a puzzle. Many of these roads survive to this day, their surfaces worn smooth by centuries of use. Roman bridges were another feat of engineering. To traverse rivers and ravines, the Romans built sturdy structures using stone, brick, and concrete. The key to their durability was the use of the arch, which allowed bridges to support heavy loads without collapsing. The Pons Fabricius, built in 62 BCE, still carries pedestrians across the Tiber River in Rome, a testament to the enduring strength of Roman construction. The Romans also excelled in the design of public buildings. Their amphitheaters, such as the Colosseum, were marvels of organization and crowd control, capable of seating tens of thousands of spectators. The Colosseum's complex system of vaults and arches supported multiple tiers of seating, while its hypogeum, a network of underground passages, allowed for the dramatic appearance of gladiators and wild animals. The use of concrete and a keen eye for structural balance made such grand spaces possible. Baths, too, were a hallmark of Roman civilization. The great public baths of Rome, like the baths of Caracalla and baths of Diocletian, were more than mere places to wash. They were centers of social life, culture, and relaxation. Engineers devised elaborate systems to heat the baths, using hypocausts, underfloor heating systems that circulated hot air from furnaces through a network of flues. Water was supplied by aqueducts and stored in vast cisterns, while waste was carried away by a sophisticated network of sewers, most famously the Cloaca Maxima. The mastery of water extended to harbors and ports. Romans constructed artificial harbors, such as the one at Portus near Rome, using massive concrete blocks submerged underwater. These harbors were protected by breakwaters and lined with warehouses, docks, and lighthouses. The port of Ostia became a bustling hub for trade, supplying the capital with grain, oil, wine, and luxury goods from across the empire. In the realm of military engineering, the Romans were equally innovative. Their camps, or castra, were laid out with geometric precision, enabling rapid construction and defense. Siege engines, such as ballistae and onagers, combined mechanical ingenuity with brute force, allowing Roman legions to breach the walls of enemy cities. The construction of massive fortifications, like Hadrian's Wall in Britain, demonstrated the Romans' ability to shape the landscape to their will. Urban planning was another area where Roman engineering shone. Cities were laid out in grids, with streets intersecting at right angles. At the heart of each city was the Forum, a public space surrounded by temples, basilicas, and government buildings. The Romans introduced innovations such as multi-story apartment buildings, called insulae, and complex systems for waste removal and fire prevention. Their attention to detail and concern for public health set new standards for urban living. Temples and religious buildings also benefited from Roman engineering advances. The Pantheon in Rome, with its vast dome and oculus, remains one of the most remarkable structures of the ancient world. The dome, a perfect hemisphere, is made possible by the use of lightweight pumice in the upper layers of concrete, reducing the weight borne by the walls. The oculus, a circular opening at the apex, not only provides light but also reduces stress on the structure. Nearly 2,000 years after its construction, the Pantheon's dome remains the largest unreinforced concrete dome in the world.